Shall we start, Dr. Shamnas?
Sir, they will come soon, sir. Only 5 more minutes, sir.
By the way, I want to tell everybody, there is a chance that there is an interruption because there's a power problem here. This morning we had a power failure about 20 minutes. So please do not leave the meeting even if there is an interruption. I request you to stay on. So that's very important that you understand these problems and cooperate with us. Okay. So, Dr. Shamnas, shall we start?
Yes, sir. Yes, sir. They will come, I think. Sir.
Yes, sir. We can start, sir. And also, sir, this event is live on YouTube, sir. Now onwards, the link is there.
I think. Shall we do it after the silent prayer because it may not.
It's okay, sir. We can edit it later. No problem, sir.
Okay.
We can start, sir.
Okay, Dr. Shamnas, we'll start at in 2 minutes from now, 10:40. We'll start.
Shamnas, sir.
Okay, sir. Okay, sir.
Because 2 more minutes we have. Actually, we should start on time, but this has been our tradition, unfortunately.
Hello, sir.
Yes, who's speaking?
This is Hannah. Sir, can we start?
Yeah, Dr. Shamnas will begin in exactly 1 minute. Yeah.
Okay, sir.
Or you, I think the MC will begin or Dr. Shamnas, who? I think Dr.
Sir, MC will start.
You have told her, right? Okay.
Yes. Everything we arranged. Sir.
Okay.
Hello and welcome. Myself, Fatimatul Hanna, 5th family. I welcome everybody for the ISPOR National College of Pharmacy Student Chapter presenting webinar on Nobel Update 2020. It's an honor to welcome you all. I hope that all of you are safe and healthy. Before beginning, let's have a remembrance of our beloved mate Muhammad Farsan. May his soul rest in peace. Now I welcome Dr. Shamnaz M., Head of Department of Pharmacy Practice, for the opening remarks. Sir, please.
Thank you, Hannah. Thank you all. A warm good morning to one and all. ISPOR. ISPOR is the leading professional society for health economics and outcome research. ISPOR is dedicated to improving healthcare decision making. We believe that every healthcare decision should be informed by the best scientific researchers. Toward this goal, the society's mission is to promote health economics and outcome research excellence to improve decision making for health globally. As we know, ISPOR, the Professional Society for Health Economics and Outcome Research, it is an international multi-stakeholder non-profit organization. The society is the leading source for scientific conferences, peer review and Medline indexed publications, good practices, guidance, education, collaboration, and various tools in the health economics and outcome research field. So, as the field of health economics and outcome research has grown in importance, ISPO's community has expanded to more than 20,000 individual and chapter members from 110 countries, more than 110 countries worldwide. The society's membership includes a wide variety of health stakeholders, including researchers, academicians, assessors and regulators, payers and policymakers, the life science industry, healthcare providers, patients, engaged organizations, etc. The society has served as an unbiased resource and catalyst for innovation in the field for more than 20 years. And I'm here to give a welcome speech for conference. So today's event, as we know, is the Nobel Update 2020. I would like to welcome our honorable and most respected principal to this event, Dr. M.K. Unnikrishnan, sir. Welcome you, sir. Also, I'm welcoming the various head of the departments of National College of Pharmacy and various other colleges, colleagues, dear ISPOR family and friends, and my dear students. I might likewise want to offer my sincere thanks to our regarded principal and all the organizers of ISPOR chapter of National College of Pharmacy for organizing such a great event. Our sports chapter organizes various conferences constantly for students to gain knowledge associating with them various aspects of life. Once again, I'm thanking you all for participating here and I wish you a very nice day to all. Thank you all.
Thank you, sir. Thank you so much. Now, we shall move to the heart of the webinar. I welcome Dr. M.K. Unnikrishnan, sir, for the session, The Nobel Legacy. So, please, I'll be sharing the screen. Can you please wait for a second?
Yes, I can see the screen now. Now, I request Dr. Shamnaz and other co-hosts to admit the people as they come. We still have a lot of people expected to come up in this program.
Sure, sir. Sure, sir. We'll do it.
Yeah. Let me begin by an overview about this Nobel, and then particularly about what India has done and what India has missed in the process of these years. So, the Nobel legacy and India is the title. There's a small correction. The Nobel legacy was the title given in the brochure. I've added another two words, and India. So I would like to start with the Nobel legacy, which is a very important event. And I would like to say that the Nobel Awards should be discussed by academics like this in the medical profession, because it is one of those landmarks that change the course of man's destiny. Healthcare delivery is just a part of it, and we must be aware of it. Universities in the West even announced prizes for predicting Nobel Awards. We did introduce one prize in 2017, and we have been following it up. And every year we get a lot of suggestions from students. And last year we even got a winner who predicted correctly. And a few more have predicted this year's prize last year. So it's a bit ahead, that's all. But they still identify the important contributions. Now, the history of Nobel Prize starts with Alfred Nobel, who had 355 inventions and many patents to his credit. And his obituary, when he read, was "The merchant of death is dead." It was not his own obituary that he read. Actually, his brother died, and they made a mistake of naming him instead of his brother. And they called him the merchant of death because he was the inventor of dynamite, which was used to detonate big, it was a bomb-making kind of explosive. So he was considered a person who could, mass exterminate human beings, and that was why he was called the merchant of death. But he was extremely upset with that announcement, and he changed his will and bequeathed around 94% of his total assets. Can you please change the slides now? I have already changed the slide. Yeah, Anna.
Sir, can you please inform
Yeah,
so
I'll
that
do
I
that.
can.
I'll do that. Yeah, I'll do that. Okay. Now, I told you to change it. Can you change it to the next one? Yeah. Now, yeah, that's it. So upset, he changed his will and bequeathed around 94% of his total assets to reward people who conferred the greatest benefit to mankind. So that is what made a difference, and that is what we have today as the Nobel Prize. His net worth of the Nobel Foundation today, not today, in 2007 was about $560 million. So that's the kind of money he bequeathed, because he was an enormously rich man because of his patents, which he won money from. Now, the prize-winning institutions like the Norwegian Nobel Committee, the Royal Swedish Academy, the Sveriges Riksbank, the Nobel Assembly of Karolinska of Physiology and Medicine. And these various awarding institutions award different prizes. Norwegian Nobel Committee gives the Peace Prize. The Swedish Academy of Science gives the Physics and Chemistry Prize. The 68, the Riksbank gives the Economics. Nobel Assembly at Karolinska gives the Physiology of Medicine, and Swedish Academy gives the Literature. So next slide, please. So what happens is there's an elaborate choice system, because it's not easy to decide who has done the best, isn't it? And there are so many conditions. You cannot give it to more than 3 people. You cannot give it to somebody who's dead. So they have to pick up a living member who has contributed substantially and also did the work when he's alive, and he should still be alive. So So the Nobel Committee receives around 3,000 nominations filed between September of the previous year and the current year. Nobel Committee sends 3,000 names, 300 names out of the 3,000. They pick 300 names and send it to the prize awarding institution. And the pricing awarding institutions, I told you, the Norwegian Nobel Committee for Peace, Swedish Academy for Physics and Chemistry, and so on, they decide after a careful scrutiny, they pick the winners. And there is absolutely no such thing as giving it to a dead man. And because of this, some people have missed the prize because after nomination and after choice, they were not able to give it to a living man. In fact, they call the person and inform him personally on phone that you won the prize. Many have woken up from bed and received the information with great joy and sometimes surprise. Nominees do not get disclosed for at least 50 years. So we don't know who is nominated now until 50 years from now. Next slide, please. The Nobel medal is a priceless treasure. Of course, you might have heard of the story during, I recall this incident some time back. Medals of German scientists Max von Lohe and James Frank were sent to Copenhagen for safekeeping. In fact, when the Nazis took over Germany, they were very skeptical about, or they were very dangerous to the very promising scientists, and they were actually driven away. And they were afraid that their Nobel prizes will be confiscated, so they sent it to Denmark, and Denmark was also invaded. You will be surprised, the medals, Nobel medals, was dissolved in aqua regia. You know that aqua regia is the only acid that can dissolve gold. They did that, and that is the way they hid the gold from the medal. After the war, the gold was recovered from the solution in aqua regia, and the medals were recast and sent. And back home, the contrasting image is that the Tagore medal has been stolen, and that was the case stands closed in 2010. So that's the situation in India. Next slide, please. Now, you will be surprised that Nobel medicines prizes have gone 66% to the English-speaking countries, about 129 out of 196. Now, these are data which are about 3 or 4 years, 3 years back, I think. So it's been slightly modified today, I think, at the latest date, with details. And the Jewish laureates, that is the Jewish-speaking, the Jewish religion, the Jewish people get the maximum Nobel prizes. Around 20% of the Nobel prizes have gone to Jews. 9 for peace, 13 for literature, 23 for economics, 25 for chemistry, 47 for physics, and about 27% in medicine. That's 53. Jews constitute just 0.2% of the world population and 2% of the US population, but 36% of the Nobel laureates are Jews. This is a very crazy thing. And on the right, you have some tables. You can read the different countries who have won Nobel prizes. You know, India has won just, of course, India has a few, but in science, we have only one. And that is what is the most expressive. In science, it is only C.V. Raman who got the prize for the work in India by an Indian. You will see that, and it's very unfortunate that we have such events going on. It's very sad. Next slide, please. Next slide is very critical because I would like to say that the Nobel Foundation can also go wrong in choosing the prize winner. You will be surprised that the Nobel Medicine Prize was awarded for leucotomy, that is lobotomy, that is the frontal lobes are severed, the connections are severed with the brain. That's for extreme psychotic conditions. And following the Nobel fame, 5,000 lobotomies were performed in 3 years after the prize, and 50,000 lobotomies in USA by 1951. So the Nobel fame can also lead to a lot of disaster. In fact, this is exactly what happens when a person becomes famous for the wrong reason. And John F. Kennedy's sister herself was lobotomized. One of the victims was the president's sister. And in 1954, thank God, a few years later, chlorpromazine came, and that's how psychosis was controlled medically. It even replaced the electroconvulsive therapy and insulin coma therapy and things like that. But chlorpromazine never got a Nobel Prize. That's the irony. So what saved the mankind never got a Nobel Prize, and what killed so many or what disabled so many won the Nobel in 1945. This is 49. And this is one of those very glaring uh, contradictions that we see in the Nobel Foundation going wrong. You know, India also has contributed to the treatment of schizophrenia with reserpine, but it's all forgotten. In fact, chlorpromazine and reserpine came one after the other. Reserpine only a few years after chlorpromazine, but India is never remembered for this. I'll explain these reasons later why India is not so powerful in cornering the prizes. It is mostly social and political rather than purely intellectual. Next one, please. Next slide. Now, there is another error which is worth mentioning. Another notorious Nazi supporter, an Austrian physician, who got a prize for treating dementia with malarial infections. That is, he induced malarial infection for treating dementia. And this was accepted and even praised and won the Nobel Prize in 1927. So you can see that the Nobel Foundation does go wrong in choosing people who are not exactly the right type of person for saving the mankind. And he was notoriously anti-Semitic, and he divorced his first wife just because she was a Jew. He even advocated forced sterilization of mentally ill patients and criminals and genetically inferior races. India could have been labeled as a genetically inferior race in his times, and this was the colonial mindset. And these are issues which we should probably understand when we look at the Nobel Prize as the ultimate achievement. Now, next is the slide, please. Change the slide, please. Yeah. The next thing I wish to discuss here is that India has been very, very bad in the Nobel Prize race. The only Nobel Prize in Science for work done by an Indian in India came during British rule. That's a crazy thing. When we were under the British, we got the only Nobel Prize in Science, and that was by C.V. Raman. And C.V. Raman was not the only Nobel class scientist in those days. Ramanujan was there, G.N. Ramachandran was there, Satyen Bose, Meghnad Saha, Bhabha, Mahalanobis, E.C.G. Sudarshan, Yellapragada Subbarao, Amal Roy Chowdhury. There were many, many more. I cannot name them all. And for some reason, these people never made it. Of course, mostly socio-political reasons. And what happened after independence is really what hurts us. In fact, before independence, we had better scientists than after that. Our curricular ambitions got redefined after independence. The IIT and medical entrance exams defined middle class ambitions. There was no further ambition in them except, making money, becoming big man, and so on and so forth. So the national priorities shifted from scholarship and knowledge towards money. And India did succeed. India has made a lot of money. It has become money through education. Even when you want education, the purpose is money. You want to be rich, and therefore you get educated. Education by itself became a smaller priority in India, and that's one of the reasons we don't have enough Nobel class scientists today, despite great advances in technology and other socio-political factors. Even within India, we have moved a lot forward, but we don't see that progress happening in cutting edge science. we are lagging. In fact, we are lagging worse than when we were under the British. This is a tragedy which you should all understand as students and how it affects us. Okay, next, please. So the top scientists uh, from Indian science and technology, it's very interesting to tell you that. 1 minute, please. You can hear, no? I hope I can hear. You can hear me. Am I visible?
Yes, sir. Yes,
Yeah.
sir.
Okay.
You're
Okay.
audible.
Okay. I just thought the connection was upset. Okay. The top 10 achievements of Indian science and technology in the 20th century was recounted by Mashelkar in an article in Hindu in 2019. Actually, he quotes Jayant Narlikar. Jayant Narlikar is another great man who has written a book also on this, which I read recently. You can all read it. So he recounts the greatest achievements in India. The first five come before 1950. Uh, I don't know. 1 second. I thought the camera is on. Doesn't matter. You can hear me, right? Yeah. And the slides are there. Okay. So the 10 achievements before the 1950 were all individual achievements. So in fact, Jain Adlikar calls them uh, individual efforts from Ramanujan, Meghnad Saha, Satyan Bose, C.V. Raman, and G.N. Ramachandran. So these are individual efforts before 1950. And then what happened is after 1950, the world changed. Science became a group uh, enterprise. Unless you are in a group, unless you are in a lab, unless you're part of a team, it's not possible to become a world-class scientist. So that's what happened in 1950. The post-1950 situation became a very different environment. And that's probably the reason why, the next slide, please. The second five achievements after 1950 are all government directed. They're not individual. The green revolution, the space research, the nuclear energy, the superconductivity, and transformation of the CSIR in the 90s. This is what he quotes, Mashelkar quotes as the five achievements. Some of them which coincides with the ambitions, the achievements that have been listed by Narlikar. Now, if you look at the next slide, please. The Indian Nobels in science are not just two. We have around four in science. I have them here in the slide. C.V. Raman in 1930 for physics. Chandrasekhar, who was an Indian, his Raman's nephew, but he went to US to get his prize. That's why he's not an Indian prize. You can say he's an Indian, but in a US citizenship. And then came Hargobind Khorana. Hargobind Khorana in medicine, he got prize when he worked abroad in 1968. In fact, he and Nuremberg shared the Nobel Prize for the genetic code. In fact, he is one of them who unraveled the code, the genetic code. Today, you have the triplet codons, etc. So he and Nuremberg are the ones who achieved it. Very small. It's not a small achievement at all. It's a tremendous achievement. And Venkatraman Ramakrishnan in 2009 was the last Nobel Prize from India in science. And he got it for chemistry. And that was for his work on ribosomes. And the next slide, please come to the next slide. There are some glaring omissions, of course. In India, we have had a lot of problems, achieving what we really deserve because of the colonial mindset. And that was possibly the reason why a person like Gandhi missed the prize. Gandhi was nominated for peace in 1937 to 39, and the Norwegian Nobel Committee later expressed regret for not having chosen him. See, look at that. It's not that he was not nominated. It was only that they did not find him eligible. So that was the colonial mindset. And in those days, that was colonialism was very deeply prevalent, and this is the price we paid for being slaves under the British. So in 1948, when Gandhi was assassinated, no Nobel Prize for Peace was ever awarded at that time. So that is probably a respectful remembrance of that omission. I think we can interpret it that way. There are others who missed the Nobel Prize too, like E.C.G. Sudarshan, Robert Marshall. Uh, they first formulated the successful theory for weak interaction. But unfortunately, Feynman published it first and won the prize. E.C.G. Sudarshan figures as an informal allusion. That's what they say. And there are some more such things. Next slide, please. Like Subhash Mukherjee, he should have won the Nobel Prize with Albert for in vitro fertilization. In fact, the second test tube baby in the world was born just 67 days after the first was born in England, Mary Louise Brown. Kanupriya Agarwal was the second baby, was born in India, and the technology was entirely from India. We published the technique of cryopreservation in 1978, 5 years before others. And Subhash was destroyed by Indians. By that time, Indian political system had matured into a very disastrous condition in which the government of West Bengal even conducted an inquiry to check what Subhash has done. Instead of praising him, they transferred him to a department of ophthalmology where he could not function and prevented him from traveling to Tokyo and presenting his work. Such is the kind of torture he faced, and finally he committed suicide in 1980. So this is what happens to genius in India, and there is good reason why India is not very successful when it comes to things like Nobel Prize and great achievements in science. It's something to regret. And there is a lot more like this. The next one, please, is also an important story that you must read about, because this Amal Kumar Roy Chowdhury, who died in 2005, he is the one who provided a key tool for Penrose, Roger Penrose, uh, and Hawking. This Roger Penrose Hawking singularity theorem is what won the physics Nobel Prize this year. Of course, Hawking is dead, so Penrose got it, and two others. So two others and Penrose, who got the Nobel Prize, are sitting on the credit, no, on the achievements and on the contributions by Amal Kumar Roy Chowdhury. You must see it. There's a documentary on Amal Kumar Chowdhury. It's on YouTube. You can easily find it. Just do a Google search and you will find that very interesting video. It just explains how simple this man was. Next slide, please. So you must listen to that video to understand the depth of his, his simplicity. In fact, I must add that Amal Kumar Roy Chowdhury was not very successful in India. He had a lot of difficulty in the early years until he left everybody and started working alone. He did not get much support from the institutions that took him up where he was employed. He finally retired from everything and he took up teaching and he became an individual researcher. Completely in isolation he worked. And it's only upon his work in isolation that he achieved something. And you know, when he went to Texas, he was invited for a conference. And in that conference, he was honored by Fred Hoyle, and Jayant Narlikar, his student, was also there. And in that conference, he remembers how Fred Hoyle was surprised to see him so young. Fred Hoyle had expected Roy Chowdhury to be a very elderly man because the kind of contribution from him was extremely complex and very important. So we had such people. We had such people until, and he died in 2005. The documentary which I happened to see was just recorded, I think, the previous year. And Rai Chaudhary was, because he taught in Presidency College and he retired. But even after his retirement, even the year before he died, he continued to work all by himself and with the students who approached, all for nothing, without any. In fact, he was very late in being appointed to various governmental positions and fellowships in the academies and so on and so forth. It came as an afterthought after a lot of years passed. Next slide. Yeah, this slide. Yeah. There are many more losers like him, E.C.G. Sudarshan, Homi Bhabha. They were also nominated more than once. They never got it. The nitric oxide signaling system was the combined work of Chandra K. Mittal and Farid Murad. Farid Murad won the prize. Mittal's name does not figure in the list. Satyan Bose did not get the Nobel for Bose-Einstein statistics, but a few got the Nobel Prize based on the work which Satyan Bose produced. Saha's thermal ionization is a stepping stone for many Nobel Prizes, but he did not win any. Biresh Guha was a pioneer in vitamin C. Nobel Prize went to an Hungarian, Saint Gorgai, and Guha was imprisoned for freedom struggle. So these are the traditions that we have in history where we have not been very kind, and the world has also not been very kind to the great scientists of India. What is unfortunate that even the country, our own country has not been very encouraging. So please be ready to fight against the tide if you want to be an individual in science, especially cutting edge science, which not many people understand. Next slide, please. Now, we are very poor in group tasks. When, I told you before 1950, we had many individuals who were shining. But after that, unfortunately, science became group tasks. That is team effort. And when it becomes a team, not many are able to do well because the team breaks up quickly in India. It's very unfortunate. And Balram, in his editorial in Current Science, has mentioned this. Unfortunately, there seems to be little appreciation of the need to integrate science and medicine in India. In fact, medicine Nobel is not likely in India because the scientists don't talk to medical people, and the medical people are not interested in the core sciences. The turf battles between the Ministry of Health and the HRD will ensure that regulations and control dominate discussions on education. The kind of educational regulations that we see today imposed upon us, we get very little freedom. The academics are the ones who lose their freedom first. And the academicians generally turn into administrators to escape this kind of regulation and turn into regulators instead of being regulated by the system. So this is unfortunately the system that we have nurtured in this country, and that's one reason why we are not doing pretty well in science today. Well, I think I can stop this talk with the summing up by Balram, but I want you all to go home with the thought that India is not unsuccessful because of talent deficit. No, we are enormously talented people. We have a lot of great people within India. Unfortunately, we haven't been able to translate our talent into a successful discovery or invention. In fact, we are going to consider many more programs like this in which we recall the traditions that India built up and lost. Okay, thank you very much, and let me stop here.
Thank you so much, sir. It's a bundle of information and it was really fruitful. Um,
Yes, is there any reason for the delay? Anna?
Sorry, sir. It was my mic was unmuted. Ms. Amila Sainuddin, fifth farm day for the. Hello, Amila, can you hear me?
Yes. Am I audible?
Yeah. Okay, you can share your screen now.
Okay. Is it visible?
Yes, you continue.
Okay. Good morning. Myself Amila, and I'm here to take a section on Nobel Prize in Physiology or Medicine 2020.
Can you be a little louder, please?
The session is about Nobel Prize in Physiology or Medicine 2020. This year's Nobel Prize in Physiology or Medicine is awarded jointly to Harvey J. Alter, Michael Horton, and Charles M. Rice for the discovery of hepatitis B virus, a decisive contribution to the fight against blood-borne hepatitis, a major global health problem that causes cirrhosis and liver cancer in people around the world. Here they are: Harvey J. Alter, Michael Horton, and Charles M. Rice. Hepatitis, a global threat to human health. Hepatitis or liver inflammation is mainly caused by viral infections. Other important causes include alcohol abuse, environmental toxins, and autoimmune diseases. By 1914, it became clear that there are mainly two types of infectious hepatitis. The first one is named as hepatitis A. It is transmitted by polluted water or food and generally has little long-term impact on the patient. The second type is transmitted through blood and bodily fluids and represent the much more serious threat since it can lead to chronic condition, which is the development of cirrhosis and liver cancer, that is hepatitis B and hepatitis C. And yes, this form of hepatitis is insidious, as otherwise healthy individuals can be silently infected for many years before serious complications arise. And yeah, blood-borne hepatitis is associated with significant morbidity and mortality and causes more than 1 million deaths per year worldwide, thus making it a global health concern on a scale comparable to HIV infection and tuberculosis. So this is how it is. There are two main forms of hepatitis. One form is an acute disease caused by hepatitis A virus that is transmitted by contaminated water or food. The other form is caused by hepatitis B virus or hepatitis C virus. This form is often a chronic disease that may progress to cirrhosis and hepatocellular carcinoma. Here is the progression. An unknown infectious agent. The key to successful intervention against infection is to identify the causative agent. In 1960s, Barrett Blumberg determined that one form of blood-borne hepatitis was caused by a virus that became known as hepatitis B virus. And the discovery led to the development of diagnostic tests and an effective vaccine. And yeah, he was awarded the Nobel Prize in Physiology or Medicine in 1976 for this discovery. At the same time, Harvey J. Alter at the US National Institute of Health was studying the occurrence of hepatitis in patients who had received blood transfusions. Although the blood test for newly discovered hepatitis B virus reduced the number of cases of transfusion-related hepatitis, tests for hepatitis A virus infection were also developed around that time. So it became clear that hepatitis A was the test. Alter and his colleagues was worryingly demonstrated that large was also not the reason for it. Was a great source of concern that significant number of those receiving blood transfusion developed chronic hepatitis due to an unknown infectious agent. Alter and his colleagues showed that the blood from these hepatitis patients could transmit the disease to chimpanzees, the only susceptible host besides humans. Subsequent studies also demonstrated that the unknown infectious agent had a characteristic of a virus. Alter's methodical investigations had in this way defined a new distinct form of chronic viral hepatitis. The mysterious illness became known as non-A, non-B hepatitis. Identification of hepatitis C virus. Now, the identification of novel virus was a high priority. Michael Houghton, working for the pharmaceutical firm Chiron, undertook the arduous work needed to isolate the genetic sequence of the virus. Houghton and his colleagues created a collection of DNA fragments from nucleic acid found in the blood of an infected chimpanzee. The majority of these fragments came from the genome of the chimpanzee itself. But the researchers predicted that some would be derived from the unknown virus, on the assumption that antibodies against the virus would be present in the blood taken from the hepatitis patient. The investigators used patient sera to identify the cloned viral DNA fragments encoding viral proteins. Following a comprehensive search, one positive clone was found. Further work showed that this clone was derived from a novel RNA virus belonging to the flavivirus family, and it was named as hepatitis C virus. And the presence of antibodies in chronic hepatitis patients strongly implicated this virus as the missing agent. Well, the discovery of hepatitis C virus was decisive. But one essential piece of the puzzle was missing. Could the virus alone cause hepatitis? To answer this question, the scientists had to investigate if the cloned virus was able to replicate and cause disease. Now, Charles M. Rice, a researcher at Washington University in St. Louis, along with other groups working with RNA viruses, noted a previously uncharacterized region in the end of hepatitis C virus genome that they suspected could be important for virus replication. Rice also observed genetic variations in isolated virus samples and hypothesized that some of them might hinder viral replication. Now, through genetic engineering, Rice generated an RNA variant of hepatitis C virus that included the newly defined region of the viral genome and was devoid of the inactivating genetic variation. When this RNA was injected into the liver of chimpanzees, virus was detected in the blood and pathological changes resembling those seen in humans with the chronic disease were observed. This was the final proof that hepatitis C virus alone could cause the unexplained cases of transfusion-mediated hepatitis. This is the final proof that hepatitis C virus alone could cause the unexplained cases of hepatitis. Here is the summary of the discoveries awarded by this year's Nobel update. The methodical studies of transfusion-associated hepatitis by Harvey J. Alter demonstrated that an unknown virus was common cause of chronic hepatitis, and Michael Houghton used an untested strategy to isolate the genome of new virus that was named hepatitis C virus. And finally, Charles M. Rice provided the final evidence showing that hepatitis C virus alone could cause hepatitis. Now, what is the significance of this discovery? Discovery of hepatitis C virus is a landmark achievement in the ongoing battle against viral diseases. Thanks to their discovery, highly sensitive blood tests for the virus are now available, and these have essentially eliminated post-transfusion hepatitis in many parts of the world, greatly improving global health. Their discovery also allowed the rapid development of antiviral drugs directed at hepatitis C. For the first time in history, the disease can now be cured, raising hopes of eradicating hepatitis C virus from the world population. To achieve this goal, international efforts facilitating blood testing and making antiviral drugs available across the globe will be required. And that was it. Thank you. Hope you all got it.
Thank you, Amila. That was a wonderful session. Can you please stop the screen share?
Yeah, okay.
Now, I would like to welcome Fatima Mujib, PharmD intern for the Nobel update on chemistry. Fatima Mujib? Fatima?
Yes, am I
Uh,
audible?
yeah, yeah, yeah.
Okay, can I share my screen?
Yes, yes.
Um, can you stop sharing the screen,
Yeah,
Hannah?
yeah, yeah.
Okay, am I audible, right? Right, audible? Hello?
Yes, Fatima, you can proceed.
Okay. So good morning, my name is Fatima Mujib. I'm the president of Student Chapter ISPOR, National College of Pharmacy. So I will be discussing about the 2020 Nobel Prize in Chemistry. So it's a very glad news that the two super ladies, Emmanuel Carpentier and Jennifer A. Doudna, has won the Nobel Prize in Chemistry 2020. And this Nobel Prize was given for the science of pathogens. Yeah, it was given for the development of a method for genome editing. So before moving on to the slide, let me explain who is Emmanuelle Carpentier. She was born in 1968 in France, studied microbiology, genetics, and biochemistry, Pierre Marie Curie University and Institut Pasteur Paris. And in 1996, postdoctoral fellow at Rockefeller University, New York. And in 1997, assistant research scientist, New York University Medical Center. And in 1999, research associate in New York. In 2002, she has become a guest professor at the Institute of Microbiology and Genetics, University of Vienna. And now she is a director at Max Planck Institute for Infection Biology in Berlin. And the other one, Jennifer A. Doudna. She was born in 1964 in Washington, D.C., US. Her education has completed in Pomona College, and she has got a PhD from Harvard University. In 1991, she completed the postdoctorate at Colorado Boulder University, and in 1997, she has become an investigator with Howard Hughes Medical Institute. She got research fellowships in molecular biology at the Massachusetts General Hospital and in genetics. Now she is a chair professor in the Department of Chemistry and the Department of Molecular and Cell Biology at the University of California, Berkeley. So yeah, before moving on to the slide, I'm personally a very big fan of CRISPR, and I would really like to share my thoughts that it is really a very remarkable change in science that is put forward. So yeah, in 1953, there was an identification of the molecular structure of DNA by J.D. Watson and F.S.C. Crick, as you all know. And there became a need for technologies to manipulate the genetic material of cells and organisms. And it was in 2012 there became a discovery of the RNA-guided CRISPR-Cas9 system, which was a more easy and effective method for genome engineering. This has enabled the scientists to modify DNA sequences in a wide range of cells and organisms. Today, CRISPR-Cas9 technology is used widely in basic science, biotechnology, and in the development of future therapeutics. And in our topic, that is the Nobel Prize for Chemistry this year, it was got for the RNA-guided CRISPR-Cas9 system. This was first introduced in prokaryotes. So they have started the study by identification of repeated genome structures in bacteria and archaea. So it was common in prokaryotes, which were short, partially palindromic elements occurring in clusters separated by unique intervening sequence of constant length, suggesting an ancestral origin and high biological relevance. The CRISP are abbreviation for clustered regularly interspaced short palindromic repeats. I hope you know what is a palindromic repeat. The one genetic material which can be read, vice versa. Like, you can read the same forth and back. The CRISP are associated Cas genes. So this was the first thing they have identified. The Cas proteins was the first thing they have identified. They are the group of genes only present in CRISPR containing prokaryotes. This was always located adjacent to CRISPR, encoded proteins with helicase and nuclease motif, a suggested role in DNA metabolism or gene expression. It was in 2005 a unique CRISPR sequence were derived from transmissible genetic elements such as bacteriophages and plasmids. The role of CRISPR in prokaryotic defense against invading foreign DNA has got predominant. The spacer sequence is described as a memory of past genetic aggressions. So this has a role in adaptive immune system. The conclusive evidence for DNA being the target of CRISPR-Cas interference came from elegant experiments performed using a strain of Staphylococcus epidermidis. They contained a CRISPR array with a spacer sequence homologous to a gene present in a conjugative plasmid. There were three stages to be identified, that is adaptation, cRNA maturation, and interference. Let me explain in detail and I will show you a figure explaining the same. So first is adaptation. Short fragments of double-stranded DNA from a virus or plasmid are incorporated into the CRISPR array on host DNA. You can see in the figure, adaptation is the first step, and then comes a cRNA maturation. The pre-cRNA are produced by transcription and then further processed into smaller cRNAs, each containing a single spacer and a partial repeat. And third step is interference. The cleavage is initiated when cRNA recognize and specifically base pair with a region on incoming plasmid or virus DNA. The interference can be separated both mechanistically and temporally from CRISPR acquisition and expression. This is how it has happened. Adaptation, cRNA maturation, and interference. Now, let us understand more about the molecule. So based on their in vitro biochemical analysis, structural features in the two RNA molecules required for Cas9 catalyzed DNA cleavage could be captured in a single RNA molecule. So the RNA components, cRNA and the tracer RNA of the Cas9 complex fused together to form an active chimeric single guide RNA molecule, that is sgRNA. Study reveals a family of endonucleases that use dual RNAs for site-specific DNA cleavage, that is cRNA and tracer RNA. They fuse together to form sgRNA, and that is a site-specific DNA cleavage activator. And they highlight the potential to exploit the system for RNA programmable genome editing. So this figure can explain the whole thing. The 2020 Nobel Prize in Chemistry, that is the CRISPR stands for clustered regularly interspaced short palindromic repeats. It refers to repeated sequences in bacteria and archaeDNA. So these sequences are part of an immune system. If a bacterium survives a viral infection, it adds a section of the viral genetic code to the CRISPR region of its own to serve as a memory in case it's infected again. So the scientists saw that this could be used as a gene editing tool. So in summary, the guide RNA, the fused tracer RNA, they induce a scissor. The first step in the CRISPR gene editing process is the creation of a strand of guide RNA. This matches the DNA sequence where we want to make a cut. So a scissor gets activated. The scissor protein, that is Cas9, binds to the guide RNA. So in the second step, the guide RNA reaches for the target section of DNA and transports the scissor protein to it. The scissor protein cuts the DNA at this point. That is the DNA code. If the cell will try and repair the cut DNA, this process is error prone, disrupting the gene function. If we add a template, the cell will use this to carry out the repair, allowing us to edit the genetic code. So, what are the applications of CRISPR-Cas9? So, how do we use this CRISPR-Cas9 in our daily life? We can use this for human disease therapy, cells and animal models, screening of new drugs, nucleic image, detection, diagnosis, transcriptic and epigenetic edits, agriculture, food materials, etc., embryo and fetal gene editing. There are some limitations as well. So the power of CRISPR-Cas9 technology also arises serious ethical and societal issues. The World Health Organization has recently established a global multidisciplinary expert panel to examine the scientific, ethical, social, and legal challenges associated with human genome editing, with the aim to develop a global governance framework for human genome editing. I hope everyone could follow. Thank you.
Thank you, Fatima. That was a great session. It was about the wondrous discovery in chemistry. Fatima, can you please stop sharing the screen?
So can you unmute? You muted the presentation.
Sorry.
No, sir.
Yeah. Is
So,
there anything?
no, sir. Next, we will move to the early bird constellation prizes. We have conducted a contest, the Nobel prediction contest, which was conducted in the year 2019. We have some predictors and correct predictions. I would welcome Dr. M.K. Unikrishnan, sir, to announce the winners. Sir?
Yes. Can you please display the names so that I don't miss any?
Yes, sir.
Now, let me say once again, this is not the correct prediction of this year's prize. This prize was suggested in the previous year. The Nobel Medicine Prize for Hepatitis C was suggested the previous year, a year early. That's why we call them early birds. So these early birds are Ms. Sandra Putain, who also won this, who also correctly predicted the previous year's prize. That is very interesting. And the next is Mr. Ames M for predicting the Nobel Prize for 2020 in the year 2019. So they have been ahead of time in a way, isn't it? Next. The next prize goes to late Mr. Mohammed Farzan. We are very touched by this, his contribution in this group, and we miss him so much. But we cannot but announce this prize on this occasion. Let's probably remember his association with our group with great unhappiness and a great distress. So these are the three. Any more? Is there any more? And yeah,
Yeah,
and the
sir.
next person is Ms. Sri Lakshmi, who also predicted the medicine Nobel last year, and instead of having it done it this year. So there were 4 people who predicted it wrongly but rightly, isn't it? A bit early, that's all. I congratulate all of you, and let me also add a word of praise to the 2 presentations, the 2 Nobel chemistry and medicine presentations. They were really good, very clear, extremely well prepared slides with good graphics, and also I appreciate the the amount of effort they have taken to understand something which is quite uh, outside the normal curriculum. It's not easy. It's not easy to understand, grasp, and communicate something so complex like CRISPR. Very often I have to go back and read myself because I forget very quickly what I read. So these are things, these are occasions which I hope the others will understand. Uh, adds a bit of ambition to the society of students here. That's the reason I asked the 7th semester students to participate in this. I don't know how many are there. Dr. Shamnas, can you tell me how many of them have attended this program?
Sir, almost more than 100 was there, but meantime, some left and some came.
That's true. So nobody has the patience. So I wish
And
the next.
live YouTube streaming was also going on, sir, same time.
That's true. But it's very sad that we don't have a good participation. No, these kind of programs are not easy to achieve. See, with just student inputs, remember, most of it has come from students. It's not so simple. It's not so
No,
simple.
sir, outside colleges also there, sir.
What do they do?
Outside
They
colleges, college people
have
also
attended
there in this. Yes, sir,
in
yes,
this.
sir. Dr.
Oh,
Subhash
really?
Philippi is there, sir.
Oh, really? That's great. Okay, okay.
Sir,
Ah,
Subhash, sir, can you hear,
Subhash,
sir?
can we say hello to you? Yeah, maybe he's not connected.
Is
Well,
there, sir?
yeah, that's good. I'm glad that people are picking up this.
Hello.
Hello, Phil, Subhash. How are you? Thank you for attending this program.
Yeah.
I hope you liked it. Huh?
Definitely, sir.
Yeah. No, we are trying to raise the level of thinking among students in our college, and ISPOR is a great platform. Fortunately, we have got a chapter here, and some of our students are very enthusiastic,
Okay.
like the ones. Unfortunately, we lost one of the most enthusiastic persons in this group. He died 2 days back. So we are in a very we are still not recovered from the shock of his departure. But I'm glad our students cooperated and came around and still attended to this program. We also have made it a compulsory program for the practice school students. So those practice school
Okay, sir.
students, that is the 7th semester students, if they do not see it, if they have not been able to see in complete, they can go back and listen to the YouTube streaming, isn't it? Am I right? Yes. So the YouTube streaming is
Yes.
possible, and there will be an examination based on what you are going to. That's a part of the practice school assignment for our college, the Nobel update, to expand their horizons. So I hope Dr. Subhash will agree with me that this is a move in the right direction, isn't it? Don't you agree?
Definitely, sir.
Thank
Definitely,
you.
sir.
Thank you very much. He's a guest from outside. We are very proud to have people from outside like Subhash. Subhash is a very thinking individual, and we are very proud to have him in this group. Thank you very much, and bye, Subhash, for a moment. We'll meet again. Yeah. Thank you. Over to
Thank you, sir.
Anna.
Thank you, sir.
Yeah. Yeah. Thank you. Anna.
Sir, can we get the feedback form, Phil? I
Yeah.
have shared it through the chat box. Please,
Yeah.
participants and others, please complete the feedback form.
Yeah, and I would like to add that it's only if you return the feedback form, you get the certificate of attendance. If you just are present, you will not get it. Is that okay? And the practice school students will also get a question paper based on what you listened today. And that is part of your assignment. Thank you. And let me congratulate Hannah, Fatima, Amila, and all others, if I missed
Thank you,
any,
sir.
the students who have worked very well. I'm really impressed. I'm really impressed for the show you have put up, despite all the technological problems that we are facing. Thank God we did not have a power failure until now.
Yeah,
We don't know when it's going to come. But anyway, now we are reaching the end of the program,
yeah,
so
yeah.
we hope that yeah. In fact, we even got some people to get the UPS fixed and all that. They're still working on it. Unfortunately, the problem started because yesterday there was a very big power shutdown in the whole of Mukkam. So that's the thing that we had. Anyway, I'm very happy to be a part of this program. It's one of those programs that we have always been conducting ever since my joining. We missed the 2019 because of the uh, unexpected, but we did conduct it again in 2020. The 19 issue was presented in 2020 on 25th of January, if you remember, that was a part of the FTP program. And we are doing it again, but then 2020, January program did not contain the prizes of this year. So that was a different program. So I'm very happy to Dr. Shamnaz. Thank you for organizing this program with meticulous care. I'm very happy. And also Dr. Akash, who has
Thank you, sir. Thank you,
given
sir.
us all the technological support, and
Yes.
the management also for encouraging these ventures, which are very, very useful to an ambitious society of students. Thank you very much. Now, has Anna got all the feedbacks? Or shall we go on waiting till they all feedback?
We will wait for 5 to 10 minutes, sir. It's okay. By the time.
Okay.
So,
Yeah.
or
Then
we can move to the next part, sir. Let them do, sir, that one.
yes, yes. Okay.
Next one is Anna.
Next one is Thanksgiving. That's by myself.
Okay.
Okay.
I think you can start now.
So myself, Fatimatul Hanna. I'm a fifth Farm Day student, and I really thank for this opportunity which was given for me, and by principal and Shamna sir and Aga sir for supporting with the technical areas, and I I really thank everyone for participating and cooperating with this event, and I gratefully thank all the dignitaries from the other colleges and all the participants of the. I congratulate the winners also for the early bird consolation prizes, and thank you very much.
Fatima, I have a small appeal to you. Can you please send me the list of people who attended this?
Sir, I
It's
have
recording,
WhatsApp.
sir. It's already recording.
No, recording. Even the attendees.
Yes, we will get, sir.
Yeah, no, I want to preserve these in the file,
Yes, sure, sir. Sure, sir. We'll do it, sir.
because these are all things which we have to submit to ISPOR also.
Yes, sir.
Okay.
Sure, sir.
You understand? So ISPOR is, quite a strict organization. They require our feedback also. Yeah.
So I think the participants have all filled up the feedback form.
And I would like Anna
Sir.
to review the feedback forms and give us the overall statistics.
Okay, sir.
That is, how many participants, what is the average opinion about the program, and I don't know what questions you have asked them. I would like you to send me a copy of the list of questions in the feedback, which I would like to keep preserve in the file,
Sir.
because this is easier if you have all the data. The next year's program becomes easy.
Okay,
You will
sir.
all go, I'll be alone. That's the problem.
Okay, sir. So thank you all of you. I think we can conclude it now. So
So shall we stop the
Shamna.
live?
Yes, yes, sir. Yes, sir.
Thank you very much once again to all of you. Wonderful
Yes.
session. Thank you. Wonderful.
Thank
Bye.
you. Thank you all. Thank you all. You can leave now.
So, good, yeah. That program.